Alright guys, so today we're going to be talking about how to rationalize the denominator. Rationalize means getting the radical out of the denominator, and the denominator is just the bottom half of any fraction that you're given. Before we get started, I want to go over what it means to have a radical. So when you're taking the square root of a number, let's say you're taking the square root of 4. In order to do this, you would need to do a factor tree, and you would get 2 and 2. And anytime you have a pair, that's going to be your answer for a square root. And the reason this works is because it's normally not written, but it's understood that taking the square root is the opposite of squaring it. And there's an invisible 2 up in that corner. Now, let's say we were taking the cube root of the number 8. All right? So instead of needing a pair of 2's, or any pair, we're going to need groups of 3. So let's go 4 and 2, 2 and 2. I'm going to cross out this 4 because I used it. I broke it down into primes. I now have a group of 3 identical factors. So the cube root of 8, I need to have 3 identical factors, and that's also 2. Now let's go with the 4th root. We break it down to 8 and 2. 8 goes away and becomes 4 and 2. 4 goes away and becomes 2 and 2. Because this 4 is up here, we need groups of 4. 4 identical factors. Once I have a group of 4, that is my answer. So see how 2 is the answer for all of these, but I have different groups of 2. I've got 2 2's here, 3 2's here, and 4 2's here. It all depends on what this number is up in that corner. All right? If there's no number written, it's a 2. If there's a number written, it'll tell you what number it is. All right, so now let's go to some examples for rationalizing the denominator. So my very first example is going to be square root of 20 all over 3 square root of 24. I'm going to draw a line over here and think, what's the very first step we want to do? Is 1, reduce. Before we rationalize the denominator, let's see if we can reduce it and see if we can make it go away. So square root of 20, I can break down into 4 and 5, 2 and 2. This becomes 2 because I have a pair of 2's. Anything left over, this 5 stays inside. So that top, the numerator becomes 2 square root 5. Let's see what the denominator becomes. So we've got square root of 24. We're going to say this is going to be 3 times whatever that becomes. So 24 can break down into 4 and 6. 2 and 2. 4 goes away. 6 becomes 2 and 3. Okay. I've got a pair of 2's here, so that comes out. The 2 and the 3 are left over, so we multiply them back together, and we get what 2 times 3 is 6. So the denominator becomes 2 root 6. All right, let's see if we can reduce here. 2 and 2 reduce, so I'm left with square root of 5 over 3 square root of 6. So instead of having to multiply both top and bottom by the square root of 24, now I only have to multiply both top and bottom by the square root of 6. The reason this works is because if you look at this, you're technically only multiplying it by 1. Square root of 6 divided by square root of 6 is just 1. Now, anything inside our radical, we can multiply. So 5 times 6 is 30. That cannot reduce. Anything on the outside, we're going to multiply. There's technically a 1 here. So 3 times 1 is 3. 6 times 6 is 36. Let me make some more space here. So we get square root of 30 over 3 times, the square root of 36 is 6. And now I'm left with square root of 30 over 18. Now, both 18 and 30 are, they're even, so we can divide both by 2. But, see this radical? You cannot combine these two because they're not like terms. If you have a radical up here, you can't combine it with any number or simplify it with any number down here that's not inside a radical itself as well. So, this is your final answer. All right. Let's do a second example. Say we have 4 square root of 6 over the cube root of 2. Okay, so this time we have a cube root instead of just a square root. So to rationalize, it's going to be a little bit different. We can't reduce any of these. They're already in their simplest form. Now, because this has a 3, instead of multiplying it just once, both top and bottom, we have to multiply it twice, both top and bottom. The reason we need to do this is because, see how up here it was a square root, so we only needed 2. I see 2 square root 6s, so it cancels out. Down here, because you've got this 3, then we need to see 3 cube root 2s. That's the only way to get it to cancel out. So if we have, I'm sorry, this is supposed to have a cube root up there as well. Say we have 4, anything inside the radical I can multiply. So 6 times 2 is 12, times 2 again is 24. Down here, we have the cube root of 2 times 2 is 4, times 2 is 8. Again, we can break this down into a factor tree if we want. I know that this bottom's going to become 2 because I did that in my example at the beginning. Let's see if 24 would break down and give us 3 equal factors. 2 and 12, 2 and 6, 2 and 3. Oh, I see 3 equal factors. I'm going to keep the 4 out front. I'm going to rewrite the cube root of 24 as 2 cube root, and then this 3 that's left over, it's going to go inside the radical. Now, anything outside the radical I can reduce. So this 2 and this 2 can go away, reduces to 1, and I'm left with 4 cube root of 3. That is my final answer.